Now we're going to graph the secant function, which of course is the reciprocal of the cosine. So to save us a little bit of time in the video, I've already got our x and y axes scaled the same way that we scale it for the cosine function. Period of 2 pi, amplitude of 1. Starting by graphing that cosine function, cosine starts at its maximum, back down to an intercept, minimum, intercept, maximum. And it does the same thing off to the left, intercept, minimum, intercept, maximum. And just like the cosecant function, the secant will be undefined everywhere. The cosine function is 0, so we're going to create those vertical asymptotes at all the intercepts of the cosine function. And then we're going to take the reciprocal. Again, those easy ones are the max and mins. The reciprocal of 1 is 1. Reciprocal of -1 is -1. And then we'll find those values of 1/2 and flip those as well. So for the secant function, we've got approximately those points. We'll make our 2's. So the cosecant and the secant function, just like the sine and the cosine function, they look very much the same. They're just shifted over from each other based on where sine and cosine are each 0. So we've got the parabolas again. And then we need one more parabola in either direction, so our graph doesn't really fit for both of them. Since we stopped at 2 pi and -2 pi, that works well for the cosine function, but for the secant, we only get half that parabola in, so we'll squeeze in those other two. Domain for this one is odd multiples of pi over 2. So x cannot equal pi over 2 times n, where n is an odd integer. All of the even integers, the multiples of pi, do work, but not those odd multiples of pi, and we have that organized on our vocab sheet. Range is the same for secant and cosecant, so y is greater than or equal to 1 and less than or equal to -1. So going over that set notation again, -infinity to -1 and 1 to infinity. Vertical asymptotes, same as the domain except for x equals a vertical asymptote at all of those odd multiples of pi over n, and the period, just like the cosine function, is 2 pi. If you're not quite sure how to find the period on this one because of the way the parabolas are oriented, it's between two of the asymptotes. So we could, for example, look at the asymptote at -pi over 2 and the asymptote at 3 pi over 2. We need both an up parabola and a down parabola for the full period of the secant function. From -pi over 2 to 3 pi over 2 is a period of 2 pi. And again, I've got all of this organized for you on your vocab sheet as well. So what you may want to do, I'm looking now and I forgot to specify, the n for the asymptotes should be an odd integer, so you may want to jot that in your vocab sheet.